All right, welcome to The Explainer. Today we're getting right down to it. We're talking about the absolute foundation of cybersecurity, computer networking. You can't really understand the fight if you don't first understand the battlefield.
And really, this quote says it all, doesn't it? If you don't know how data gets from point A to point B, how can you possibly attack it? Or more importantly, how can you protect it? It's all about knowing the roads. So with that in mind, let's dive right in. Just think about it for a second. Every single cyber attack you've ever heard of, ransomware hitting a hospital, a state-sponsored group going after a power grid, all of it, every last bit, happens on a network. It is the terrain. It's the digital ground where all these battles are fought. So what is a computer network really? At its most basic level, it's just two or more devices talking to each other. That's it. It could be as simple as your PC telling your printer to print something, or it could be the mind-boggling scale of the entire internet, with billions of devices all chattering away at once. Okay, so obviously networks aren't one size fits all, right? They come in all different shapes and sizes, from something in a single room to one that spans the entire globe. And that scale, it really changes things. So let's break down the main types. First up is the LAN, or Local Area Network. And you know this one intimately. Even if you don't use the name, it's your home Wi-Fi network. It's your phone, your smart TV, your laptop, all connected to that one little box, your router, and sharing that one internet connection. That's a LAN. So as you can see here, it really is all about scale. We start with a LAN, which covers a single building, like your office. Then you scale up to a MAN, a metropolitan area network, which could connect a whole city. And then the big one, the WAN, or Wide Area Network, which connects, pretty much everything. The internet itself is the ultimate WAN. All right, so we've got the scale down, but how are these networks actually, arranged? The physical layout of a network is called its topology. And you can think of it just like a city map. Some are neat grids, others are chaotic. This layout has huge implications for everything from speed to, you guessed it, security. Let's go back to that home Wi-Fi example. All your devices, your laptop, your phone, everything, they all connect to one central hub, the router. That's a star topology. Now, from a security perspective, this is a real double-edged sword. On one hand, it's great because all the traffic goes through one spot, making it easy to watch. But on the other hand, that hub is a massive single point of failure. If that router goes down, your entire network is toast. Next, we have the bus topology. This one's a little more old school. Just imagine one single cable, the bus or backbone, with a bunch of computers tapped into it in a line. The weakness here is pretty obvious, right? If that main cable gets cut or fails, the whole thing goes down. Plus, it's not great for privacy, since data sent down the line could technically be overheard by every other machine. And then there's the mesh topology. This is the big one when it comes to reliability. In a true mesh, every single device is connected to every other device. It's an absolute beast of redundancy, which is why you see it in places like the military. Why? Because there's no single point of failure. An attacker can't just cut one wire to take it down. The data just says, okay, no problem, and finds another way to get there. Okay, so we've covered the layouts, but how does the actual data, travel? How does an email you send from London magically appear on a screen in Tokyo? Well, it's not magic. It follows a very strict set of rules, a protocol stack. That's kind of like a digital postal service. Let's follow the mail, shall we? What we're looking at here is the TCP/IP model, a simplified 4-layer guide for how data gets packaged and sent. It all starts at the top, in the application layer. That's the program you're actually using, like your web browser. From there, the data moves down through the layers, getting wrapped up and addressed for its trep, until it hits the bottom layer and gets sent out over the actual physical hardware. But here's a really cool part. Your data, say a big email or a video you're streaming, doesn't get sent as one giant file. Nope. It gets chopped up into thousands of tiny little pieces called packets. Each packet gets sent on its own, and they might even take different routes to get there. Then, on the other end, they're all put back together in the right order. It's an incredibly efficient and reliable way to do things. So, if you've got millions of these little packets flying all over the world, how in the world do they know where to go? Simple. Every single device on the internet has a unique address. It's exactly like how your house needs a street address for the mail to get to you. And that address is the IP address, the Internet Protocol address. This is the fundamental building block of internet routing.
It's what makes sure that when you search for something on Google, the answer comes back to your computer and not the one next door. It's the digital return address for every packet.
And what's really interesting is that these numbers aren't just random. They're actually organized into different classes based on how big the network is. So you have Class A for the absolute giants, like your internet service provider. Class B is for big places, maybe like a university. And then you have Class C. If your home IP address starts with 192, that's what you've got. It's designed for small networks, just like yours.
So when you put it all together, the different network sizes, the topologies, the protocols, the addresses, what you really have is the blueprint for the entire digital world. This is the map. And whether you want to build things, defend them, or even analyze how they get attacked, it all starts right here. After all, you can't possibly protect a castle if you don't even know where the doors are.
So, now that you know the map, what's next? Where are you going to explore first? Because with this foundation, you can start asking the really interesting questions. How is data encrypted? How do hackers exploit these protocols? This is your launchpad into that world. Thanks so much for watching.